Right, guys. Hello. We're going to keep on going. We're getting very close to the end. Lesson 79 today, lesson 80 tomorrow. There is an investigation. We'll have a quiz on Friday. And then your last test next Wednesday, which I probably will post on Tuesday. We'll see how we do with the review next week. So let's keep on going and talk about angles exterior to circles. What is an angle that's exterior of a circle or to a circle? Okay. Then I said the exterior of the circle is the set of all points outside the circle. So an exterior angle has its vertex outside the circle. What does that look like? Alright, so actually let's draw lines. It means that there's going to be an angle outside, exterior to a circle. Okay? There's a theorem that says the measure of an angle whose vertex is the outside of a circle is equal to half the difference of the intercepted arcs. Okay? You need to keep your postulates and theorems handy, even if you're looking at them in the back of the book. Okay? If you're not writing them right now. I understand I'm not going to keep up with that. So it's just up to you to find them and look at them. Okay? So the measure of an angle whose vertex is outside, so this measure angle A, or they put a little 1 there, angle 1, is equal to half the difference of the intercepted arcs. Now, we've seen something like this before. This one is a little different because we are subtracting it, not adding it. Okay? And we have to subtract the bigger arc minus the smaller arc. Those are our two intercepted arcs. Okay? So angle A, or the measure of angle A, will equal 1/2 the difference of the measure of arc CE minus the measure of arc BD. That's what theorem 79-1 says. Okay, that's the basic gist. We're subtracting the arcs and then we're taking half of it. Okay? Is it okay if one of these lines is not a secant? This line AE. What if we drew something that was a little crazier? I'm going to draw a smaller circle over here and draw some lines. One that's a secant. Remember what a secant is? It's just a line that goes through a circle, hitting it at 2 points. One that's a secant and one is a tangent. Does it still have 2 intercepted arcs? Yes, you have an arc here to the point of tangency, and then you have the smaller arc on the inside. Okay, you can still do it if it's tangent to it. Okay, so let's give some numbers. If this arc over here is 110 degrees, and my angle, let's say this is 110 degrees, and my other angle is 70. Other arc, is 70 degrees. Can you find the measure of angle 1? Right here. We plug it into this formula. Angle 1 equals half of 110 minus 70. Well, what's 110 minus 70? I gotta think about that. It's 40 degrees. What's half of 40 degrees? Angle 1 is 20 degrees. Okay? That angle right there would be 20 degrees. Okay? Now, could you solve this if I gave you different pieces? Could you do it? Okay? I hope that answer is yes. And all you have to do, you've got an equation. Oh, I didn't use my lines. Okay, so I'm going to give you, this angle right there is 18 degrees. And I'm going to give you this arc right over here, we'll even use the CE, is 84 degrees. What is arc BD? Question mark. So that's the question. What is B to D? What's the measure of B to D? Okay. Now, you're still going to use the exact same formula. Okay. Except for that little angle that was equal. Angle 1 equals, or angle B equals. You know what it is. 18 degrees equals 1/2 of the larger arc, which is 84 degrees, minus the smaller arc, which we don't know. So I'm just going to put an X there. Okay? How would you go about solving for X? It's algebra. Rearrange an equation and solve for X. I personally, lots of different ways to do this, but I personally would love to multiply both sides times 2. That makes that half go away. Times 2. What's 18 times 2? I'm pretty sure it's 36. So I have 36 equals 84 minus what? How do we solve for X? I don't know what you do. If you're subtracting 84 and then taking the opposite, it's okay if you do that. I know that I need 84 minus 36. But really, it's 36 minus 84. But you subtract numbers by using the smaller one. 4, 2, 8, and that is a 7, not a 1. Why did I put a 1 there? That's 48 degrees. X equals 48 degrees. Okay? Very good. You should be able to solve either piece. Okay? What if I give you a different? Watch this. What if both pieces are tangent? Okay, I'm going to draw a line where the exterior angle is tangent to the circle on both sides. And I ask you to find the measure of angle 1. And I give you, from here to here is, let's say 140 degrees. And I want you to find the measure of angle 1. Do you have enough information? That's a good question. Do you have enough information? Hopefully a lot of you said yes. If these are both tangents, what does this arc on the outside have to be? Yeah, it has to be the rest of that circle. So we have to do 360 minus 140, and that's going to give me 220. So 220 degrees is this outside arc. Now do you have enough information to solve for angle 1? Yes, you do. We're going to say angle 1 equals 1/2 of the bigger arc, which was 220, minus the smaller arc, which was 140. So that's 60, 70, 80. That should be 80 degrees. What is half of 80 degrees? Angle 1 equals 40 degrees. Okay? That's all this lesson is. They talk about the arc addition postulate, which we could have used right there. They give one where they give the outside, and that's, oh my goodness, that's pretty much it. Okay? They use an application of the moon and the earth. The lunar eclipse covers an arc of the earth in a moon shadow. If observers are in the 168 degree arc experience, a full or partial eclipse of the moon. Okay? So, that angle is only, they solve it if you're on page 519 with me following along, it's only 12 degrees over there. Okay? So that you can see two circles. Would it work here if we used two circles? It should. There's the moon, and there's the earth. And if you fall on the line, yeah, it's going to be tangent to both. So I just need to do this and then draw them, and then put the moon in there. where we have two tangent circles, and they're asking, they give us this angle right here. Whoa, totally didn't mean to do that. Let's do this. Okay. This arc was 168. Could you solve for this angle right here? Okay. Then that if the sun is over here, there would be a lunar eclipse. Okay, but what angle is that going to be at? Okay. That's pretty much it. All right, homework. We don't have a lot left. So we're going to do lesson 79. We're going to do the practice. You do not have to do letter A. So you're only going to do B through E. The practice, B through E. And then numbers 1, 5, and 8. All right, that's it. I'm trying to keep them short here at the end. I know attention spans, including my own, slipping away. I will talk to you guys later.